Thanks for coming and hanging out with me in the basement today. What I've got is the GP7 from the Northern Freight Flyer set. I did a video on like a few videos ago. I'll put a little card up here for that video. But we're going to see if we can fix the original electronic unit in this. What it was basically doing is you'd put it on the track and it wouldn't do anything unless you gave it a nudge, and then it would just jump to life. And it would run good, but unless you stopped it, then it would stop and not start. So got some great ideas from people in the comments about things to try on the circuit board to look for. So let's get started on fixing it. Alright, let's see if we can at least get it to run. Maybe just sitting around has healed it. Not very likely. Alright, we're on track 2 here. Actually, we're on track 1. I apologize. There we go. Okay, we do have a cab light here. We got a bright light. So the contact rollers are working because the light is bright. Oh, there we go. Went reverse. Whoa. Okay. So it's kind of doing the same thing it was doing before. Let's pop the shell off here. I've already got the screws off. Okay. Put it the other way. So here's our circuit board. What I'm going to do is I'm really going to check out that switch first, make sure that that's working correctly. And then we're going to clean up the circuit board real good. I did insulate this with some electrical tape, just a temporary measure. This circuit board does not look very bad on the bottom, to be perfectly honest with you. But there can be cracks that can happen in here, and we can touch up the solder joints. We can also check out the capacitors to see if any are totally dried out. I noticed that all of the negative lines on the capacitors all go toward the outside of the board, so that's a good sign. I'll make it easy. Oh, this has 4. I'm assuming these are, yeah, tip 32. These are high-powered transistors. Could be something up with them as well. But let's get started checking out the switch. Ooh, what do we got here? Whoa! Look at this! The switch broke off. That's one of the wires for the switch. Or one of the terminals. It's gotta be. It's a little flat blade there. Alright. Yeah. That is a good sign. I'm happy that happened. Let's get that switch out of there. Okay, that's good to know. Oh, what do we got here? This is another part of the switch. Yeah, the back part of the switch. Oh, is that where the other terminal went? Interesting, it had a solder connection here, but somebody moved the solder joint to there. This is interesting. Well, I think I'll unsolder this one and we'll do a little testing on it. Okay, we got it on the track. I got the electrical tape back on it. We got the wires disconnected. Let's see if it does the same behavior. Okay. Let's try connecting these together and see what happens. We still could have something wrong with the board. Okay, so connecting those together basically shuts down the board. See if it returns to its normal behavior. There it goes. Okay. No change. Worth testing out though, and good to know that disconnected means the board's going to work. Alright, let's look at some of these capacitors. This one might be leaking. I see a little residue on the bottom of it, so I think I'll check those out next. Alright, so what I brought out is I'm going to do this a little bit old school. I got the trusty Hakko here. No need to worry about what the actual number is. It's just arbitrary. It's not calibrated or anything. But we got the soldering iron. Need to get some solder though. Alright, this is 6040 lead solder. Kester brand, but as long as it's 6040 and good quality, don't worry about it. Let's see here. So, another main thing that's really handy to have is this kind of copper curly Q stuff to clean the tip. Works really good. So what I mean by old school is I'm not going to get out the vacuum desoldering station because I just really don't want to. We're going to do this old school. Basically, I'm going to pull out this capacitor. We'll test it with my limited testing ability with the 1 meter, and then we'll try putting in a different capacitor and seeing if that improves it. Like I said, this one's right here is the one that's physically showing signs. It's got some leakage, or appears to be leakage on the bottom. I don't see any other sealer or anything. Sometimes in like old radios they'll put like some sort of sealer on them. This does not, none of these caps have that, so I think that this one's bad. So this is a solder pulp, by the way. This is a spring-loaded device. It's got a plunger inside of it, and when I press the button, it creates a small amount of suction quickly, and that'll suck up the solder. At least that's the idea. Okay. That worked perfectly. Solder is removed from this point. Well, let's hit the other point. Oh yeah. Whew. There we go. Yeah, just look at all that crusty stuff around there. That's got to be from the capacitor leaking out. Let's get my meter out. That is the capacitance. Alright. See if we can measure anything here. Hmm? 1.125 UF. Let's see what one of my other ones are. Let's try a new one. Okay, we got a 2.2 is the closest I got. I don't think it's going to be too critical. Yeah, 2.1. Yeah. So this thing, even though maybe something leaked all over it, I don't know, appears to be good. I'm going to keep troubleshooting, and I'll let you know what I find out. Okay, so I just found out something extremely interesting. I was getting ready to hook up my logic probe to check the outputs of this dual flip-flop chip here. And so I don't want to blow this thing up. I had it set to like, 5 or 6 volts. And when I started doing it, it worked perfectly. I thought it was because I had my test leads on it, but then I took them off. It still works. What happens when I move it up to 9 or 10? Then it fails to work. Or work reliably. Back down to 5? Or 6? Isn't that weird? I'm going to keep working on it. I'll let you know what I find out. Very strange. Okay, I turned off my movie light. I wanted to show you. This is my logic probe. It tells you if a circuit is high or low. And I just kind of wanted to show you what this thing is doing. So, visually show you. I'm going to try replacing the chip. It's only like a 70-cent chip, so I'm going to try that. But if I put... Let's put it on like 13 volts here. And we put it down near the bottom. These are the outputs, these 4. So on this first set of outputs, we got low. So sometimes she does crank out. So now we got high. low, high, low. So it's maybe something starting to work a little better inside that chip, but it definitely seems to be caused. It doesn't seem to like high voltage here. So, like I said, here we got high, low, high, low. So that side's actually working correctly. This side, on the other hand, we got low. So just the state of the voltage here. It just stays low. Unless I lower the voltage way down to like 5 volts. Let's try 5.5. Then it goes to high. Otherwise, if I zoom it way up, it just stays on high most of the time. So that's kind of why I'm thinking there's something in the chip, because I measured the voltage to the chip, and it's definitely within spec. This chip can handle like something like 15 volts or something. It's a high power. It can handle high voltage. So that's why I'm thinking it's something in the chip. But this chip is only like 70 cents, like I said before. So, you know, $10 in shipping for one chip. But yeah, well, that's kind of how it goes. But I'll report back once I get a replacement chip. I gotta inquire out to one of my friends. We'll see if he's got something. Here's something I didn't think I'd really be showing. Working on Lionel's, doing circuit board repair. We'll get we'll move the camera a lot closer here, but what I've got is going to replace this chip. I've got replacement chips here. I bought it from Mauser, but there's a lot of electronic suppliers out there. But these are a whole bunch of chips. Basically, my friend is going to be buying some of these because these chips are used in pinball machines and whatnot. Not too much, but in a couple machines. I'm going to keep like 4 of them for some spares, just because they're so cheap. They're like, I don't know, $1 a piece or something like that. But they come packaged like this, so you get them a little cheaper if you buy them, if you buy them in bulk. And I'm going to add a socket. Not that I expect this to go bad, but you never know. So we'll have a socket sitting here. And then we can just, if the chip were to go bad, we could just swap it out. That'll work really good. But what I've got here is, this is my handy dandy desoldering tool. It's meant for desoldering components from a circuit board without damaging the circuit board, even though this end gets hotter than a regular soldering iron. And it's got a button here for suction. So that sucks in the solder and it traps it right in here, and you just empty this out every once in a while. Works really good. But that is a desoldering station. And then here I've got the standard. You've seen this before on the channel, but this is what I use to solder stuff. Another good thing about using a socket is you're just soldering here, soldering the socket in, and you're not heating up the chip. You just slide the chip in and go. But I'll pull off one of these chips, and I'm not worried about static discharge. Yes, it could happen, but these chips aren't that susceptible to it. So let's get this. They really mangled the end of this container here. All right, let's pull one out. Oh, 1, not 4. So here is the chip here, and now it's on the floor. So let's get started. Okay, so with this chip, we've got the notch, which is on the left-hand side as I'm holding the board here. That'll be important for the replacement chip. That means the replacement chip will go in like that. There's the notch here. So we've got a CD4013BE, and we're changing out a F4013 BDC. It's the 4013 is the main thing. This was made in 1984, and this guy, I'm not sure how the date package works on this, but this is much newer, made by Texas Instruments. Let's get this guy out. So let's get some helping hands over here to hold the circuit board in place. There's no power through it, so I'm not really worried about shorting anything out. Not the best, but this should work. Move you over just a little bit here. Alright, let's get cracking. Let's get a little more light in here, though. I may have to resolder these just to desolder them. It's kind of weird how that works, but it does work. I heat up the solder real good with the tip of the gun, then I pull the trigger to suck up the solder. I did pretty good on that, but I think this one's a little bit tight here. What I'll do is I'll grab a pair of pliers and I'll just kind of wiggle each one, and if all of them wiggle free, then the chip will fall out. Oh, that one's good. Excellent. Good. That one's tight. You don't want to force anything if you can avoid it. That one's now loose. 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 Loose, loose, loose. This being a single-sided board, this is a lot easier to work on. Oh, we only got one tight one. That's good. Okay. We'll just try heating it up just a little bit. Still got something holding on just a little bit. I don't want to force it. Alright, so this side's clearly out. It's the back side we're having trouble with. Okay, so what's the problem? Probably this guy. We could cut the chip away too. Alright, that looked pretty good. Let's see if that was it. Oh, there we go. Look at that, ladies and gentlemen. One chip successfully desoldered. Okay, now all that's left is the easy part. I just need to take my desoldering iron here and get any residue that's in the pipe here. Otherwise it'll freeze up, or that can be safely shut off now. Hopefully. And hopefully we don't have to turn it on again. And then we just take our socket. Socket also has a notch on it. Just lay it right in there. It sits in real nice. And then we just solder it up. Alright, let me plug in the other soldering iron, or turn it on here. Again, it doesn't matter what I have the solder, what I have the temperature set to. Just, it's not even calibrated, so it could be hundreds of degrees off, but this thing heats up pretty darn quick. I really like it. Okay. Now get to my favorite tip cleaner here. Make sure we're hot enough. Perfect. Let's see if we can get you in nice and close. Let's see how this goes. Clean tip. A little bit of solder on it. Heat up the joint. Beautiful. Just gonna go right down the line. Okay, I need a little more on this one. Okay. Well, see, we pulled some extra solder from these joints, so a little bit over here. Heat them up a little bit. Okay, excellent. Those look good. There's nothing bridged out. Oh, we gotta need a little bit of solder back here. Touch up some of these. Just making everything look pretty. Maybe use a little more. Alright. That is it. That was quick. Turn off the soldering iron. Our socket is all installed correctly. We have our new chip. Now the chips come spread out a little bit wide. I could use a chip installer. I do have one, but this is a pretty small chip, so we'll just kind of manually bend it just a little bit. There we go. The chip is in. The legs are not all bent to heck. We are ready for testing. Let me move the stuff out of the way and we'll see if my theory worked and this chip was bad. So I've got my thin layer of protective tape on the bottom here. And like I said, let's see if anything works. It might blow up. It might work the same. I don't really know. Let's find out though. Alright, I got it on. Let's see, we need track 2. Let's bring up the voltage. Cross our fingers. Alright, here's the test. It would not do... Oh, it's 9 volts. It's already working, but let's go for 12. Well, it's working good. What did I use to secure that circuit board? Use a little bit of double-sided tape. And also I covered the circuit board with this. This is not duct tape. This is gaffer tape. If you've never seen this, it's a fabric tape that the adhesive on does not stick to what you put it on. So this is what they use in the film industry to kind of like cover up cords and whatnot. Paste cords down or tape cords down. And when you take it off, the adhesive just doesn't get all gooey. It's really nice, but it's also more expensive, but well worth getting a roll. But yeah, she is working good. I'll test her out here. Works beautiful. Well, what can I say except it's working! It is working beautifully. Every time I think or say it's working, I always think back to Star Wars Episode 1 where Anakin's in the pod racer and goes, "It's working!" It's one of those things, I guess. This guy's kind of noisy, so we'll shut it off for now. But just using my experience with electronic circuits and a little bit with the type of chip that was, logic chip, you know, and using some tools, I was able to figure it out. You know, a little bit of a shotgun approach with the capacitors, but that's pretty much a safe bet anytime. You know, capacitors are always going to be a little potentially bad. But I'm really glad I fixed this. Let me know what you guys think. And hopefully I don't have to do too many more of these electronic repairs. I mean, granted, kind of know how to do it, but I do like working on the post-war stuff that you don't have to worry about electronic stuff. That's okay. Let's get her rolling. Beautiful. I'm very happy with this. Let's do a full speed run here. We'll probably end up whipping the caboose off. Woohoo! That's fun to do every once in a while. Thanks for watching. You can't make that up. Don't worry. They're just cheap cars. I'm okay with that. It's funny how the caboose stayed on, though. That was good.